Good afternoon. We are here again to continue with data management track. And thanks a lot for all the questions you posted. Our team is working with the answers. Keep asking also during the data management track, where we will cover today the data reference architectures of data management in the cloud, Qlik Cloud data integration capabilities, Snowflake, and at the very end we will have a common discussion about uncluttering the data. But let's start with the first topic about reference architecture of data management in the cloud. It will be Svilans, myself, and my colleagues, system architect Simas Baranauskas.
Hello.
And when thinking about what are the data management in the cloud, we often call it the modern data stack. And when working with the companies and what I have typically seen in any given company, there is a gap. There is a data team, technical people who know how to write SQL statements, how to access the data, and there are business people who only they know the context of the business situations for which they require the data. Often in between there are business analyst teams who know how to write SQL and how to talk with the data teams to prepare the data, and they're also talking with the business communities to prepare this information. And modern data stack is actually there to help that initiative to bridge that gap and bring the data more closer to business operations to extract the value from it. And when we're talking about the data extraction, data access, there might be different stages in that process or readiness in which companies need modern data stack. Let's talk briefly about that. So, how typically analytics is beginning in the companies? Mainly, it's one source from which everything has started, be it ERP systems, CRM, whatever. And in this scenario, there are just few people, or one or few, who know this source, who work with this data. They probably have some tool like Excel, Power BI, Qlik, any tool actually. And the need is to quickly make some report, extract some information out from that one data source. And very often it's enough for that. You have to start somewhere at some point. And in this source access is starting to become more difficult, but there are some cures. So typically companies trying to make a replica of that source, provide of course read-only access to the data, but there are situations you have to merge data with another data source or third data source. You might try to use BI tool to merge this data together, which is possible, but it has some limitations as well, and the performance is missing. But there's clear sign when you probably will need to move to the next stage. So it's an ever-growing number of the data sources, or you have teams needing access it from other locations of your company, and the number of users are growing. So you cannot provide users for every single data source separately. There might be BI tools are not capable of dealing with these data volumes anymore. And business requires more sophisticated visualizations. So that stage is called data lake stage. So in short, we are taking data from one or two or many data sources, ingesting that and putting into one single location called data lake. It's still raw data as it comes. Maybe you can do some filtering when selecting what you share there. But already the companies and users are gaining some benefits, like there is a managed single access to the data source. You have better control over that. You can solve performance issues, and you can put even larger queries, the larger data sets. But still you have to maintain some skills, like for example, to query these various data sources, you have to keep somewhere wiki page with the SQL snippets to share this knowledge. You don't have an unified semantic layer yet. and it's again a sign. You can see some signs when users start arguing about the data. So it's not yet a single source of truth. So they are demanding it to have one reliable source. And you might also face situations when you have to separate changing data structures in transactional source for the reporting need, where you need to have more homogeneous environment and deal with these slowly changing dimensions and things like that. And maybe there is a need for artificial intelligence, machine learning. So the next stage in that situation would be a data warehouse, which combines a data lake where you can ingest, land the data, and bring it together in some ordered fashion to cure the data, to improve the data quality, merge the information together, and provide curated, confirmed, single source of truth to your business communities. And the business can really trust this information. In some situations, we can develop some specific data marts for some use case, but that comes from the data warehouse. And we at Infotrust have this modern data platform consists actually of very different pieces of technology. If you browse on Google, you'll see so many offerings there. What we have done at Infotrust, we very carefully have tried and proven alignment of these different technologies that we will show in the future and future slides. And Simas will explain why exactly we have chosen these technologies for our reference architecture. Simas?
Hello, everyone. So, yes, I will go a little bit more deeply to each of these components. And as Marius said, we have tried each of them and quite many alternatives. So I will maybe focus on each of these tools, why we chose them, what exactly it gives you in a certain point, and what are the benefits. So in this slide, we can see that we are ingesting the data to Azure Data Lake. And for that, we are using Data Factory as orchestrator and ingestion engine, the pipelines in Data Factory. And when the data is landed into the Snowflake, in a bronze layer, as we call it, and we'll get to the layers also in one of the presentations explaining a little bit more about what are those layers. But in general, we have the data in Snowflake. And for transformations, we're using dbt Cloud for transformation and documentation of all those transformations and data movements. There are alternatives, of course. For Data Factory, you can use Airflow, which is quite often used in the world. For Snowflake, for last 4 years, we were implementing also Azure Synapse Analytics, and we can compare those two tools very in a deep level. But at the end, we chose the ones you can see right now. And if we are going further, the first component is the data lake, which Marius already told a little bit about. Data lake is, in general, it's just a storage for any kind of files, any kind of information. Why to use data lake? It's because it's durable, it's high availability, it can have replicas in other geographical regions. It is protected from any disasters, and this comes out of the box. You don't need to administrate that, or you have scaled machines, load balancing, and all those technical things. You don't you don't care anymore. And the price for data lake and data storage is very convenient. It's 9 euros per terabyte for a cool storage and 18 euros per terabyte for premium storage per month, which includes all the administration. Security, because they have all kind of security control of accessibilities. And the accessibility is also a different level, I would say, because that data in data storage can be accessed from any kind of tools, using REST API, using machine learning tools, Python notebooks. They can access that data by giving them the certain permissions. But in general, it's just a place where we land all the data. Do we need it right now? We will need that later. It doesn't matter. It's a storage where we will have all the data. Orchestration and ingestion engine. In our case, that would be Data Factory. We are working with Data Factory for, I think, six last years. And comparing to other tools that we were using before that, what benefits it gives you at the very beginning? First of all, the monitoring. In monitoring, in each Data Factory pipeline, you have the very detailed information about each run, how long it took, how many megabytes of data was transferred, how long it took to read the data from the source, like in this case 4 minutes 25 seconds, how long it took to transfer, because sometimes customer is asking, is it a good idea to transfer 10 gigabytes or 100 gigabytes from on-premise to cloud every night? And actually transferring is one of the least issues, transferring time. And writing to sync is very interesting point to track, because different tools have different writing speed, I would say. For example, in SQL, when you are writing data to SQL Server, it takes 10 times more time than writing to a data lake. Because SQL is kind of checking each line, checking each consistency of the data. And data lake is just writing simple writing operation. Monitoring is not only about how long it takes, how much data we processed, it's also about setting the actions. What happens if, for example, the certain pipeline crashes, or there is an error in a copy data activity, for example. And you can set up what happens when you reach that point. Of course, you need to alert the maintenance team, but can you proceed with the same pipeline? Should you jump to next pipeline? All the actions can be set up in this orchestration tool. Complex cycling data loads, while you can set up not a simple pipeline, but like in this case, a pipeline that, in this case, actually, it was reading 200 databases, looking for the same information in each of the database. And in each of the database, it was querying only the new data, all data that we have already, skipping. And in these cases, you can set up parameters parameters for a pipeline, parameters for a data set, global parameters on all data factory. And by using those parameters, you can set up quite a complex pipelines. And it gives you clear visual understanding of the data flow. Comparing to the scripting tools that usually we have, it's you need to go through lots of lines and in your head understand how they are connected and where exactly is jumping the flow after error. And here you have the visual understanding what exactly is happening and what sequence and so on. And you build, on top of these pipelines, you build pipelines that are managing the pipelines, master of pipelines. It's for orchestration, because when you finish the ingestion, you need to start the DBT part that will do the transformation, and you need to wait until it finishes. When it finishes, then you need to reload the Qlik applications, and maybe not to reload them all at once, but maybe wait for until one is finished and then jump to another. So orchestration of pipelines is critical when you have, for example, we have customers that have 200 pipelines. And with 200 pipelines, and in each of those you have 40 different steps, you need additional tool, a visual tool to manage that. Just by scripting, which would look like this, it's almost impossible to manage loads like this. But in this scripting part, or sometimes you jump in this scripting part because for quickly replacing the data set with another one just by find replace. Next one for orchestration is out-of-the-box connectors and data factory. Data factory has many connectors like Microsoft CRM, Salesforce, Business Central, BigQuery, Google Analytics, any kind of connectors are just out of the box. And in my experience, it's only the custom-made solutions with custom APIs. You need to add them themselves. But even that is possible. You can add your own connector to this tool. Integration runtime for on-premise data. In some cases, not in some cases, in many cases, you need to access the on-premise data. And usually it's a very secure perimeter. You cannot just open on-premise data to cloud, just simply to cloud. You need to set up either the private network or whitelist the IPs or use the any other tools. And in Data Factory, it is solved very easily. It has integration runtimes that solves that problem. And you install integration runtime on self-hosted machine. And during installation, it requires special key that your data factory was providing. Your data factory, not just a general, but exactly your data factory instance is providing this key. And during installation, integration runtime connects to this data factory. And from that time, it answers and proceeds requests only from this data factory. And all communication between data factory and integration runtime is encrypted. All infrastructure providers like DataBank, Bluebridge, and they already know this integration runtime, and we have no problem to access the on-premise data. You just send them the new key and installation, and in 15 minutes, everything is set up. So, on-premise data factory, easy to use and scale. Easy to use and scale because the pipeline has visual editor, and you can have, as you see here, the monitor. You can monitor how it was run last night, night before. You can clone it. You can export that as a template and maybe import to another data factory. And scaling solution is so easy that in some forums, experts are talking about that as a in sense of weakness of data factory, because in a month you can create so many pipelines that it gets a messy. Too easy to create new ones. But using some discipline, of course, it's not a bad thing to have such a functionality. Data warehouse. I finished about the orchestration and ingestion engine as a data factory. We're jumping now to data warehousing part. And the next session will be whole about Snowflake, which is a chosen platform by Infotrust. And I will just quickly go through the main benefits for those who will not attend the next session. The performance. Snowflake is very, very fast. And from our experience, the tests that we were running with queries for 100 million rows, it was running faster 3 or 4 times faster than on signups on data lake. Not even talking about SQL, because SQL was the least performed tool from our experience. Scalability. In some cases in SQL, even in data lake, it runs, everything runs smoothly with 10 million rows. When it comes to 500 million rows, it's everything changes. And sometimes you need to re-engineer everything that you do, how you do, because it just cannot handle that much data anymore. And with Snowflake, it's easy. You just choose another computing engine, the more powerful computing engine, and you don't need to redo anything. Intermediate results, it's just a general benefit of having a data lake or a data warehouse, because you have not only the final result, but you have each result after each step that you can trace. If there is an error or something goes wrong, you can easily find where exactly it happened. Possibility to collect additional data, like snapshotting some information that is not stored and kept in a system. Ability to analyze data with different tools. We'll talk about that also in the next session a lot, I think. Accessing data for complete self-service, data discovery. Yeah, that will be the next session, but these points are the main for data warehousing. dbt tool. When we have data in data warehouse, why do we need dbt? dbt gives you actually it's a tool that became very popular for a very short time, and in Scandinavia, more than half of Snowflake users, companies, are using dbt as well. And why? First of all, it's management of complex lineage workflows. In dbt, each of these boxes are different transformations. And you can see which sources are used in what transformations, and result of those transformations where are used further. And in this case, for example, we have SRC orders as a result. And you can see that all the final results are using that query. So if I will touch that one, I need also to check how it will impact the tree of result transformations. models. For example, campaigns are used only in one. So I know that I don't need to test orders when I'm touching campaigns. Automatic documentation of your solution. It's very important. In our experience, I don't think that even 30% of BI implementations are documented properly. And when a new developers come in or a new company is overtaking maintenance of the solution, that is quite a problem. With DBT, you get initial documentation. Like in this example, you can see all the sources that are used for transformations. In each source, you have all the columns that it has. You can add additional description of those columns. But what is even more important, you see in a tab reference by, you can see all the further transformations that will use that source. And if I will press on pardavimai, on the fourth model that will use the source actually is sales header of document, sales document. And if I'm pressing that pardavimai, I immediately get to the transformation part, to documentation of that transformation part with all the queries inside. I can see in a line 61 that it is joined with, the header is joined with lines. And I can add a description of each column, additional description, what exactly is transformed. And I can also go to, again, depends on, and evaluate what other transformations are using this result of that transformation. So documentation, it is to have at least 90 or 80% of documentation out of the box while you're implementing. It is a lot, because to do that manually, someone will spend many hours. And if you are spending many hours for the first time while preparing that, that's one thing. But after half a month, half a year, after 1 year, is it still the actual documentation, or are we keeping that alive, or it's just a version that we had 1 year ago? And with DBT, it is always the actual version. It is always tracking, are you still using that source? It is always tracking all the connections, which is very important, I think, for mature companies. Monitoring, intermediate results, testing. You can set up, in a model, you can set up description of the column, and you can set the test. Like, for example, in this case, currency and exchange rate connection. Like, there is a column that has currency and the date, and it must be unique. And it must have not nulls, which is important for the further transformations. And the result that we have when we describe all those tests, it's like you can see how many tests failed, what tests passed, and if you will have that for your whole transformations for the test environment. Immediately after you do the change, you run the workflow, and you can see if any of the tests failed, which makes testing and development way faster. Version control. Version control is like in DBT, you always have the three environments: the testing, development, testing, and production. And of course, you are working in development environment. Then you push that to the branch of testing. You trigger the whole workflow, and in the end, you have those all passed tests, and if it works, and of course you can also have the user acceptance test that even the user says, yes, everything is okay, we push that to the production. So that is all about those key components of our reference architecture, and maybe briefly why we choose them. And the next session is going more deeply into the Snowflake engine.